Okay, so number 9, how can you increase the absorbance reading for any solution without making the solution darker at all and without changing its concentration at all? Sorry, that noise is my little dishwasher. Got that on Amazon.com. Love it. But anyways, how can you increase the... So, I'll let you figure this one out. Number 10, let me know if you have trouble with that, will you? The output from a spectrometer for many wavelengths is called the spectrum. Collect a few data points. Oh, okay, so here is the spectrum for potassium permanganate, KMnO4. That's the purple stuff in here. KMnO4. Alright, nice purple. So, this is the spectrum. This is the absorbance at different wavelengths. Notice wavelength is the x-axis. Let me show you what that means. That means this right here. This is the x-axis, and this right here, this right here, this thing right here, this is the y-axis, right here, absorbance. That's the y-axis. This is the x-axis, and we're keeping the concentration constant. Okay, it doesn't really matter what the concentration is. It's just it has to be constant. And you take a data point here, 466,0.35. You take a data point here, 595,0.16. But it has been done for you. You see, oops. You see, so some computer went in there and took like millions of data points for you. And now your job is to label regions on this graph that correspond to red, green, and blue. How are you going to know that? Well, you use the numbers here. So 380, what color is that? Well, here I could see that 380 is purple. So this is something like blue, so 427 all the way down to maybe 488, something like that. That's kind of blue, right? So on the graph, I label stuff in the graph. Now, if you're using Microsoft Word, you can just draw using the drawing tools. You can draw right on the page. However, if you're not using Microsoft Word, as I am not using Microsoft Word right now, that may be a little more difficult. You may need to take a screenshot of the graph and edit it in your favorite drawing program. Let me show you what I mean. I'm taking let me get a screenshot tool. Let me get a screenshot tool. Select area to grab, and take the screenshot. I'll just grab this area, copy to clipboard, and then I'll just get my drawing program. If you're using, I guess I can save it too. If you're using Microsoft Word, the drawing program is going to be MS Paint or just Paint. If you're using a Mac, the drawing program is going to be Mac Paint. And if you're using Linux, I don't know what your drawing program is going to be. Mine is Tux Paint. I also like to use GIMP. Yeah, it looks like Tux Paint is not letting me... Oh, yes it is. Oh, yeah, so Tux Paint is not going to do what I want it to do. So I will just use GIMP instead. My old friend, the GIMP. Open something new, and yeah, here it is. And I'm going to label on here the regions of interest. So I found that from about 488 to about 420 something, was it? This was blue. So I'm just going to write blue there. You know, it's probably better if you use something thinner. All right, like that. And then what else do I ask for? I ask for red and green. All right, so let me go back to the lab here. Green. Green goes from about 500 to about 550 something. So I'll go in here. Oops, where's my paint? Here it is. So from about 500 to about 550 right there. Right there. This portion of the curve right there, right there, right there. That's green. And then red, like 648 down to 700 maybe. Now don't, say 648 to maybe 700, something like that. So right there, that's red. Now don't use the numbers that I've used, okay? Yeah, I've just done a very rough job of selecting the colors from these numbers. And my eyes do not see exactly what your eyes see, maybe. So maybe this does not look red to you. Maybe that looks red to you. Or maybe that doesn't look red to you. So you just find what seems to be red to you. And I'll be using a pretty wide range to grade you. But I just don't want you to have exactly the same numbers as I have. They'll be close, but not exact, right? So that's what I mean by labeling the graph in this item here. Label the regions. Now, what color is the KMNO4 solution? To figure that out, you go back to the lab, you get the KMNO4 solution, and you make it pretty concentrated, and you look at the color. That's all. And then which primary colors are absorbed and which are not. So red, green, and blue are the primary colors. So I want you to look at on your graph. Here's blue, here's green, here's red. Now, which ones of these three are getting high absorbance with KMNO4, and which ones are getting almost no absorbance, right? So that's what I want you to notice and to think about. Okay, don't know what I just did there. All right, so now, and then next for number 11, use the simulation to collect data and sketch the spectrum for a different solution. So now I want you to take 12 data points, and I want you to plot them on your favorite graphing program. So mine will be Plotly. So go back, I go to the grid, and I'm going to get 12 points. And here's how they're going to look. It's going to be a scatter plot again, X and a Y. And let's see, whoops, wrong. So I'm going to take 380 and the, whoops, let me put this right here. All right, and the absorbance is 0.62. So 380 nanometers, and the absorbance is 0.62. I'm just going to do this 12 times. Yes, 12 times. I know what you're thinking. Why do we have to graph so many points? Okay, the reason is, I want you to get the idea that this is a spectrum of many different wavelengths. I want you to use your own wavelengths and look at your own absorbances and construct the graph so that you do get that idea. Alright, so then you'll just get a screenshot and paste it in here just as I showed in video 2. Now, what color is this solution? What primary colors does it absorb? So it looks like you're not going to use KMNO4, you're going to use whatever solution you prefer. My favorite color is green, so of course I want to use nickel chloride, or the nickel compound. If I were to do this problem on my own. And that's it. That is all. Thank you.